Hi everyone. So today we are going to look at inductors, and particularly we're going to look at the basic operation of the inductor and describe the VI characteristics, just like we did for the case of capacitors. Now, an inductor is basically a device that stores energy in a magnetic field, whereas if you remember the capacitor, it stored energy in an electric field. And inductors are made simply by coiling the wire up, and we'll show how this results in an inductive effect. Basically what happens is that the magnetic field from each turn induces a back EMF in the other turns and builds up a potential difference across the device. And inductance, as you should know, is measured in henries. Now, one of the relationships that you should keep in mind here is that since the inductance is related to the flux, the equation that actually relates them is L is equal to N phi on I. N is the number of turns in the coil, phi is the flux produced by each turn, and I is the current. So some current I is going to come through the coil, and that current is going to produce a flux, and you have N turns, so the total amount of flux concentrated in that volume is N times phi. So the inductance then relates the flux to the current. So if we look at a straight current carrying conductor, let's say the current is going in this direction, then what is the direction of the flux? If you remember your right hand grip rule, then the flux should be in this direction, right? So that means the right hand grip rule, if you remember, your thumb should point in the direction of the arrow, the direction of the current, and if you make a fist, your fingers will curl in the direction of the magnetic flux. So this gives you the direction of the magnetic flux. So when we have a straight conductor like this and a current goes through it and you get this flux being generated, the flux basically goes out into space. So it doesn't cut any other conductors or anything like that. Now, what happens when you coil the conductor, if we look at the current, say, going in this way and coming around the coil like this, if you look at the current coming that way, then if you again use your right hand grip rule, you should see that the flux should be going in this direction. But more importantly is that since we have a curved geometry, what is going to happen here is that the flux from one part of the winding, so when the current is coming through the winding and you have a changing current here, the flux that is generated is going to cut all the other windings. And if you remember Lenz's law, if you have a conductor in a magnetic field, then it is moving in a magnetic field. Well, in this case, the conductor is not moving, but there's relative motion between the conductor and the magnetic field. It induces an EMF that will oppose that current. So in this case, you'll induce an EMF that will try to drive current back in the opposite direction. And what happens then is that you have an EMF building up across the winding. So that has the effect of reducing the current. So if we get into the mathematics, the voltage is equal to N d phi dt, where d phi dt is the rate of change of flux. Remember, there has to be relative motion between the conductor and the flux. So this is what the d phi dt describes. And we know that L is equal to N multiplied by phi on I. So I could just do some substitutions and I should get that V is equal to L di dt. That is the differential form. And an integral form, I have I is equal to, IT is equal to 1 on L the integral of Vt dt. And what this tells me is that the current through an inductor cannot change instantaneously. So if you remember, for the capacitor, we had the voltage couldn't change instantaneously. Here the current cannot change instantaneously through the inductor. So just to summarize, we covered here the basic operation of the inductor and the VI characteristics, how do we derive the equations. Now I'm going to put up some videos for you, so very interesting videos discussing the operation of the inductor, or actually not the operation of the inductor, but the circuit laws governing the inductor when they're in circuits. So you could look at them and you could discuss those on the forums. And next we're going to look at the combination of inductors in series and parallel.